This is a monocrystalline 180 watt solar panel bought from a local shop. I intend to use it for a power supply system. This is the rear side of the solar panel, showing the connector from the solar panel and a couple of wires, positive and negative terminals. These are a couple of spanners which I bought online for connecting and disconnecting the MC4 connectors commonly used in solar panels. Both sides of the spanner are shown. Started off by stripping the sheath or insulation of one of the terminal wires using a standard wire stripper. There are special wire strippers meant for solar panel installations which I do not have. After making the wire tip bare, I started assembling the MC4 connector. This is one part, a cap. Next step is pushing in the grommet over the wire. This is a set of dismantled female and male connectors. The wires have to be connected to the bare pieces of metal on right side. There are specialized crimping tools for connecting the cables to the metallic portion of these connectors, but as I did not have them, I used standard pliers to fix the cables onto that metallic portion of the MC4 connectors, both male and female. This is the fully assembled female connector. Same process was repeated for the male connector, and now I have both male and female connectors connected to the solar panel. Female connector is connected to positive terminal. Complementary connectors were connected to the cable, pair of cables, and then you can see the corresponding pairs being mated, and it is easy to do that with your own hand. A click sound will be heard when it is properly mated, but you won't be able to unscrew it or pull it apart with your fingers. For that you need a pair of solar spanners which I showed earlier, but I have not tried pulling it apart because I don't want to have a loose connection. This is the solar charge controller. I connected the wires coming from the solar panel kept on the terrace to the corresponding terminals on the charge controller and also the battery. Interestingly, I found that the voltage of the solar panels was 0. So I have set up the initial connections are to the solar panel, and this connection goes to the battery. This is a 65Ah SMF, sealed maintenance free battery. You can also call it as sealed lead acid battery, and it goes to an inverter. That's a 1150 watt inverter. You can see that red light blinking over there. That's the inverter. This was the display shown on the inverter. The brand name is the battery voltage 12.6 volt, AC input 280 volt, but I have not connected any AC input to charge for the inverter, and load is 3 watts, system on, and heat temperature probably 22 degrees centigrade. This is the solar panel kept on the roof. You can see the MC4 connectors mated, and the cable is going from the solar panel to the house. Battery terminals connected to the solar charge controller showed 12.8 volts. After connecting the battery terminals as well, this was the voltage shown at the terminals in the solar charge controller coming from the solar panel, just 2.82 volts. I was totally confused. At this point, I was thinking of calling my friend who had supplied the solar panel and the accessories and asking him to send a technician to set it right. It was morning time, so I thought of asking my amateur radio friends who were having a conversation on radio. There were many of them. Amateur radio call signs of those who participated in the discussion mostly were VU2 XPZ, VU3 TBU, VU2 Mike India Echo, and VU2 RDL. So they all suggested that even if not illuminated much, solar panel should give an output of about 19 volts. So 2.82 is nothing to be thought of. And they also suggested that you can try connecting a 12 volt bulb of low wattage across the solar panel output and see how it lights up, and also check the open circuit voltage. As per their suggestions, I decided to check the circuit once again, and to my luck, when I pressed the MC4 connectors, the mated connectors together once again outside near the solar panel, it was really useful. This was what I found when I came back and checked the open circuit voltage from the cables, 19.3 volts. I was quite happy and very much thankful to my amateur radio friends for all the discussions on the band. So the problem was that I had not connected the MC4 connectors together properly. The actual mating was not correct. There was some loose contact somewhere. As soon as I connected the battery and solar panels to the charge controller once again, the solar icon started blinking, indicating that the battery is being charged. And the lower one is state of charge of the battery. The battery is already fairly charged when it was brought from the shop. When I came back after some time, I saw that the solar icon was brightly lit without any blinking. So I presume that it is because the battery is now in a fully charged condition, as it was already partially almost nearly charged. I connected a pedestal fan, and then the solar panel voltage now shown is 13.08, and you can see that when the load is there, icon has started blinking, solar icon, meaning that it is charging the battery. The display on the inverter had showed 67 watts load. Earlier it was 3, and now the temperature is 24 degrees, so some rise from 22 degrees, and 13 volts is the battery voltage shown. AC in, earlier it was shown as 218, now it is to 30 volt, and AC out is 218. Load is 66 watt, which you have seen. It's a rewind once again. Added a tiny additional load, that is a fish tank motor, then it became 73 watts load, and temperature has also gone up. It is 31 degrees centigrade. Probably it was starting up initially when it showed 22 degrees. Now the battery voltage is only 12.7 volts,